Everyone, this is lesson 2.5, Reason Using Properties from Algebra. In this lesson, we're going to review some algebraic properties of equality and apply them to geometric terms, so talking about segments and angles. We're going to use these properties when we start learning about proofs and the process of setting up a statement and reason column. When you're writing a geometric proof, we're going to start with algebra and then move over to the geometry types of proofs. Today, we're just focused on vocabulary in this video and some brief examples, and then tomorrow you're going to do some more examples in class as well as an assignment. So go ahead and copy this diagram down. Pause if you need to. It's just talking about all the different properties of equality. You have your addition property. So if A and B and C are any real numbers, if A equals B, then A plus B equals B plus C. So that means that if you have two sides of an equation, you can add something to both sides. So this is like if you were from addition to division, this is just like solving an equation. And you use these properties all the time when you're solving a simple equation. You probably don't think that you're using the addition property or the multiplication property. You just automatically do it because that's how you solve the equation. The subtraction property is the same thing. We can subtract a number from both sides of the equation. Since it's equality, whatever you do to one side, you have to do to the other. For multiplication, it's the same thing except you're multiplying by that number. And then for the division, you're dividing by that number. Or, you can also multiply by the fraction 1 over c, like 1/3, or multiply by 1/4. That's the same thing as dividing by 4. The substitution property. So if A is equal to B, then A can be substituted for B in any equation or expression. So think about it like if you have the expression 3x plus 7, and let's say that x is equal to 3 minus y, then you can substitute this in for x. So you would rewrite it as 3 times 3 minus y plus 7. This might remind you of like solving a system of equations. Okay, and then distributive property. I know you're very familiar with this. If you have a number and then parentheses, you can distribute that number into the parentheses if they're separated by addition or subtraction. So that has to be addition or subtraction, and you can't have any exponents. Remember, if you have an exponent like b plus c squared, then you have to rewrite it as b plus c times b plus c, FOIL it out. You cannot just distribute the square like this. That would be the wrong way. So just to recall from your algebra days last year. All right, so now let's talk about some properties of equality that involve real numbers, segments, and angles. There are just 3 here. So reflexive property. Reflexive property, think about like reflection. So it's kind of like looking in a mirror, looking at your reflection. So I think these are, yes, can I move the boxes? I think there's a way I can move these boxes, maybe. Delete. Oh, nope. Okay. There we go. So I just want to delete this box here, not everything. It looks like I can't delete it, so I'll just minimize it, I suppose. Okay, so for any real number A is equal to A. Okay, it's pretty simple. In terms of segments, what does that look like? for any segment, AB is equal to BA. So AB is the same thing as BA, so you can switch them. And then for angles, so for any angle A, the measure of angle A is equal to the measure of angle A. So that's all the reflexive property states, is that you can, doesn't matter which side they're on if they're the same thing. Or for segments, you can rearrange the order. Okay. Notice this is all about talking about the properties of equality. So notice there's equal signs in between everything. If we were talking about congruence, we would have to use segment AB is congruent to segment BA. So remember that when you're talking about congruence, you use the actual geometric segment or angle. So we would say angle A is congruent to angle A. But when you're talking about equality, then you're just talking about the measure of the segment or the measure of the angle or the length of the segment. All right, so symmetric property. Let's see what that says. For any number, A and B, if A is equal to B, then B is equal to A. Well, it sounds like the same thing as up here, but it is slightly different. So symmetric, you probably would think of symmetry. So kind of like if the way you go to work is the way you come back, or the way you go to school is probably the way you come back, or if your parents drop you off. So going from A to B is the same thing as going from B to A. It might take you a little longer because maybe the traffic is different, but it's the same route. So here's what it looks like for segments. For any segment, AB and CD, if AB is equal to CD, the length of AB is equal to length of CD, the length of CD is equal to the length of AB. So basically you could switch them around. So this seems very similar to reflexive property, but it is different. We're switching the actual segments around rather than saying this is equal to this. Something is equal to itself. So you might want to write that down for reflexive property. The difference between that and symmetric is that for reflexive property, you say that something is equal to itself. That's how I like to think about it. Something is equal to itself. But for symmetric, you're saying that if something is equal to something else, if something 1 is equal to something 2, then something 2 is equal to something 1. And then for angles, so think about what it might look like for angles. How about using angle A and B? Well, for any angles A and B, if the measure of angle A is equal to the measure of angle B, then the measure of angle B is equal to the measure of angle A. Okay, pretty simple. Transitive property. And you do have to have these terms memorized. You do have to commit this to memory. You will be given a proof, like a reasons for proof sheet that you can use on your test and quiz, but you want to be familiar with what they actually mean so that you're not scrambling on the test to figure it out. Okay, so transitive property. For any real numbers, A, B, and C, if A is equal to B, and if B is equal to C, so let me read that again. If A is equal to B, and B is equal to C, then A is equal to C. So what else does this remind you of? And we learned about it a few lessons ago. Does this remind you of the law of detachment or the law of syllogism? So this is like the law of syllogism. Which means that you can skip the middle. And actually, you can have a whole chain of equality. So you can say if A is equal to B, and if B is equal to C, and if C is equal to D, and if D is equal to E, blah, 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 blah. And then if X is equal to Y, then A is equal to Y. So you can go on and on with this transitive property. So transitive is like how you're transiting. So say you live in the city and you got to go get to work. And in order to get to work, you have to hop on the blue line, and then you have to hop onto the red line, and then finally you get at work. Well, you started at home, you ended at work. Not that you can skip riding the train, but I don't know, that's just a way to think about it. For segments, so if A, B, and C, D, and E, F, so if A, B is equal to C, D, and C, D equals E, F, well, A, B, and E, F are both equal to C, D. So we can skip the middle and just say that AB is equal to EF. And then the last one, for any angles A, B, and C, the measure of angle A equals the measure of angle B, and the measure of angle B equals the measure of angle C. They are both equal to the measure of angle B, so we can skip the middle and say measure of angle A equals measure of angle C. Now, remember that it does not matter if they say measure of angle C is equal to the measure of angle B. You can, in this case, this is equality. So for this type, for the law of syllogism, it did matter. But for this type, since based on the symmetric property, we can actually switch these around because of the symmetric property of equality, then it would not matter what order they're in. Okay, so for transitive property, you can skip the middle even if that part is not, one is the second part and one is the first part. If they're both the second part or if they're both the first part, you can still skip the middle because of the symmetric property of equality. Okay, so all of these different properties are going to allow us to prove different geometric theorems, and we're going to learn all throughout the year about different properties, postulates, definitions that are going to help us prove all sorts of different things. So that's all for the vocabulary. So tomorrow you will do some examples in class and then work on an assignment.